Good morning, Wolfpack, and welcome to Lesson 4.1, Triangles. Our essential question is, how do triangle properties assist in solving real-world problems? Let's go ahead and get started. A blank angle is an angle that is formed by two sides of a polygon with a common vertex. And that answer is an interior. Okay, think about the word inside. Inside of the triangle. A triangle has three interior angles. It has this angle, and that angle. So then there's another type of angle that's formed by one side of the polygon and the extension of the adjacent side, and that's called the exterior angle. Okay, an outside angle. Exterior angles form linear pairs with interior angles. So for example, this exterior angle right here, along with this angle right here, is forming a linear pair, forming a line, adding up to 180 degrees. The exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. And a remote interior angle is not adjacent to the exterior angle. So that exterior angle that I highlighted in yellow is equal to the sum of these two remote interior angles. It's equal to the sum, if you add them together, it's equal to the sum of those two remote interior angles. Then let's talk about y for a second. How many degrees are in a triangle? We know that all three angles have to add up to 180 degrees. We also know that this line is 180 degrees. So, if this yellow exterior angle is, let's say that it's 100 degrees, okay? That means that the adjacent interior angle, this one that I marked with two lines, has to be 80 degrees, because 180 minus 100 is 80, okay? Well, if a triangle is 180 degrees, these two angles that are left, these two remote interior angles, they also have to add up to 100. Because if all three angles are 180, and I know that one of them is 80 degrees, what's left is 100. Now, I don't know how much each is, but I know that the sum of them is 100, which is equal to the sum, which is equal to the exterior angle. So that's that drawn out. Example 1a, find x. Or the theorem says that the exterior angle, which this is the exterior angle, is equal to the sum of the interior angles. So the interior angles are the ones that are not touching x. So that's 52 degrees and 48. So x is equal to 48 plus 52. X is equal to 100 degrees. Simple as that. Example 1b. Again, this is an exterior angle, and we know that it's going to be equal to the sum of the two remote interior angles. So 52 plus 2x. Now we have an equation with one variable. We're going to combine like terms. We're going to subtract 2x from both sides. So now we have x plus 16 equals 52. We'll subtract 16 from both sides. X equals 36. And all we had to do was find x, so we do not have to go back and plug anything in. So that, again, the exterior angle is equal to the sum of the remote interior angles. The triangle sum theorem states that the sum of the interior angle measures of a triangle is 180 degrees, which I just told you a few minutes before. So the measure of angle A plus the measure of angle B plus the measure of angle C has to be 180 degrees. Nothing more, nothing less. The interior polygon, I think interior is spelled wrong. It is, I apologize. The interior polygon angle sum theorem states that the sum of all measures of the interior angles of a convex polygon with n sides is n minus 2 times 180. So basically, you count how many sides that the shape has, subtract 2, and multiply it by 180. Let's use a triangle for an example. Okay, so a triangle, n minus 2 times 180 degrees. A triangle has 3 sides. So 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180, 180 degrees. And we know that a triangle does indeed have 180 degrees as its 3 angle measures. Okay, so we can find how many angles, the angle measures of any shape, if we know how many sides it has. And n represents the number of sides. The exterior polygon angle sum theorem states that the sum of the measures of the exterior angles of a convex polygon is always 360. It doesn't matter how many sides it has. If I add up all of the exterior angles, they're always going to be 360 degrees, no matter how many sides it has. Example number 2. Find the sum of the interior angles for each of the following. Draw the diagonals from any one vertex for each polygon. So the first example, they already drew the diagonal for the first one. It says from any one polygon. Okay, so for any one vertex. So from this vertex, I can only draw one diagonal because it has to be to a vertex that's not adjacent to your starting vertex. So I could not draw a diagonal from here to here because that's just a side, or from here to here, that's just a side. Okay, so I can only draw one diagonal in this situation. So here's my diagonal. And then it says to find the sum of the interior angles for each of the following. The formula is n minus 2 times 180. Well, this shape has 1, 2, 3, 4 sides. So 4 minus 2 times 180, 2 times 180, 360 degrees. So all of the interior angles of this shape add up to 360 degrees. Well, look at what we did. When we drew a diagonal from one vertex to the other, we created 2 triangles. We have this triangle, and we have this triangle. Each triangle is 180 degrees. So I have 180 for the blue triangle and 180 for the black triangle, which adds up to 360 degrees. And sure enough, that's what I found when I solved it as well. Okay, let's do another one. So I'm going to start from this vertex right here, draw my diagonal, I see that I have 3 triangles created. So I have a feeling that my answer is going to be 3 times 180. But let's work this out. The formula is n minus 2 times 180. This has 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180. 3 times 180, which is what I assumed it would be back from the beginning by looking at how many triangles were created. And 3 times 180 is 540 degrees. We will do 1C together example 2C together in class. If you want to take a stab at it, go ahead. I'm going to turn the page to example 3. Find x and y. X and y. Well, y is pretty easy because y forms a linear pair with 121 degrees. And a linear pair is 180 degrees. So y is going to be 180 minus 121. Y is equal to 59 degrees. X is an angle inside of this shape, which is a pentagon. It has 5 sides. And in order to know what x is, we're going to have to know how many degrees everything is supposed to add up to. Well, this is a 5-sided shape, 1, 2, 3, 4, 5. And we just found on our last problem that 5-sided shapes should add up to 540 degrees. So we don't have to work that out again. So all of these angles should add up to 540 degrees. This one, this one, this one, this one, and that one. So if I subtract the 4 that I know, if I add up the 4 that I do know, I know that they all add up to 377 degrees. So 68, 121, 103, and 85 add up to 377 degrees. And I can use that information to find x. X is going to be equal to 540, which is what they all have to add up to, minus 377, which is what we already have. And when you work that out, you get x equals 163 degrees. We will do letter B in class together. The isosceles triangle theorem. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the sides opposite, if two sides of a triangle are congruent, then the angles opposite them are congruent. So side AB is congruent to side AC. They both have that one mark. So the angle across from side AB is angle C. And the angle across from side AB is angle B. That means angle B is congruent to angle C. The converse of that is, if two angles are congruent, then the sides opposite those are congruent. So angle B is congruent to angle C. That means AC, which is the side across from angle B, and AB, which is the side across from angle C, are also congruent to each other. So in an isosceles triangle, you're going to have two congruent sides, which means you have two congruent angles. Or if you have two congruent angles, you have two congruent sides. The equilateral triangle theorem says that if a triangle is equilateral, which means all equal sides, it is also equiangular, or equiangular, however you want to say it. This means equal angles. Right? If a triangle is equilateral, it is also equiangular. So each interior measure will always equal 60 degrees, because if all three angles have to add up to 180 degrees and all three angles are equal, 180 degrees divided by 3 is 60 degrees. So you want to remember 60, because if two of them are 60, the other one has to be 60 as well. Example 4a, we're going to find x. Well, I see that I have two equal sides, which means that this angle is equal to this angle. So if the left angle is x, the right angle is also x. Okay? Well, I know that if I add up x plus 3x, what do they have to add up to? They have to add up to 180 degrees. We know that. So we're going to combine like terms. 5x equals 180 degrees. Divide by 5. X equals 36. Okay? And we will do example B in class together. Let's look at example 5a. In this particular triangle, I see that this is 60 degrees, this is 60 degrees, so that means this one has to be 60 degrees, which means all the angles are congruent, so therefore all of my sides are congruent. So I don't know what x is, but I know that that side, 2x minus 3, equals 7. Simple equation, 2x equals 10, divide by 2, x equals 5. Okay? If two of the angles are 60, the other one has to be 60. That's all the option is. We'll stop right there, and I hope you understand this. Please make sure you write any questions down that you may not know in your margins, and we will go over them together. And I'll see you next class. Have a great day, Wolfpack.